Today we're going to look at lesson 7.3, which is all about more multiplication properties of exponents. So we're going to use multiplication properties of exponents today. The first one is all about raising a power to a power. So let's think about this. Let's think about x squared being raised to the third power. So there are two exponents here. Let's focus on the outside exponent, the 3. Remember, that exponent tells us that we have 3 of the x squared terms. So we're going to have an x squared times x squared times x squared. Okay, now that we've gotten rid of that exponents, now we've got exponents inside these. And so because these are exponents of 2, that means that within each parenthesis, I should be seeing 2 x's. So essentially the first parenthesis will have x times x, then another x times x, then another x times x. Okay, well, let's count up how many x's we have. Notice that we've got 2 in each of them, and there's 3 different sets. 2 plus 2 plus 2 tells us that we would have then x to the 6th power. So the question is, what did we do with our exponents? We started with an exponent of 2 and 3. Our final answer, the exponent turned into a 6. Hopefully we notice that those numbers relate with multiplication. 2 times 3 gets us 6. So what did we do? We multiplied. All right, so understanding that brings us to this definition. To find a power of a power. We are going to keep the base and we are going to multiply the exponents. So our formal definition then would be if we have an x to the m power raised to the nth power, we keep that base of x, and m gets multiplied by n to become our new exponent. All right, so let's take that idea and let's do some practice. Notice that we have 4 to the 7th power being raised to the 3rd power. So hopefully we're okay with noticing that 4 is the base. In our directions, we are to keep the base. So 4 is going to stay as it is. But because we have a power to a power, we are going to multiply those exponents together. Well, 7 times 3 tells us that we have 4 to the 21st power. Notice that in this next example, -3 in parentheses is the base. So I have to keep that base as it is. That will not change. But because we have a power raised to a power, that means that we have to multiply those exponents. So keeping the base, 6 times 7 is going to give us an exponent of 42. So -3 in parentheses raised to the 42nd power would be our answer. If we look at this third example, we have y to the 3rd power raised to the -4th. So y is our base, so that stays the same. A power to a power means we will multiply those exponents. Well, 3 times -4 is -12. Hopefully we're okay with noticing that because we have a negative exponent, this is not our final answer. Put it over 1 because I don't see a fraction. Because it's the term in the numerator that has the negative exponent that has to get moved down to the bottom to change its exponent positive. Because nothing else will be in the numerator, we will then put a 1 there. The base stays the same, but now the exponent changes to a positive. So 1 over y to the 12th power would be our answer. In this next one, we have several different power to a powers. So let's focus first on this right here. We have x to the 3rd raised to the -1st. So remember, x is in the base, it's going to stay the same. 3 and negative 1, power to a power, means that we multiply those exponents together. Well, 3 times negative 1 is negative 3. Okay, we're not going to be able to keep negative exponents, but because there's still more to this problem, I'm going to leave that for right now. I'm going to now focus, I'll change the color. Now I'm going to focus on this part. We've got x to the negative 6 power raised to the second power. So I have to keep the base, but then I multiply my exponents together. Negative 6 times 2 is negative 12. Notice that both of these have the same base. Technically, this is a multiplication problem. So this takes us back to one of our prior lessons. If we are multiplying the bases, as long as the bases are the same, we are going to keep the base, and this time we add our exponents. Well, negative 3 plus negative 12 will give us x to the negative 15th power. And now that we have one base with an exponent, because that exponent is a negative, we are going to, just like the last problem, think of it as a fraction by putting it over 1. And then we have to move the term with the negative exponent to the other part of our fraction. So because nothing else will be on the top, we now have a 1 on the top. The base stays the same, but by moving that down, the exponent becomes a positive. So 1 over x to the 15th power would be our answer. Let's take a look at one more concept dealing with these multiplication. So we have raising a product to a power. So let's think about this. Let's think about x times y squared, that being raised to the third power. Okay, when it says a product means multiplication. Notice that in parentheses, x is being multiplied by y. So there's my product. But that whole entire thing is being raised to the third power. So let's start with that outside exponent of 3. Remember, that means that I need to repeat what I have in parentheses 3 times. All right. Notice that once I've repeated it 3 times, now I have a bunch of x's and a bunch of y's. Remember, if you don't see an exponent with the x, technically we've got some 1's going on here. So because this is all multiplication, I actually get to rearrange my terms. I can actually put all of the x's together, and it looks like there are 3 of them. I can put them in one parenthesis. Then I can put the y's together in another parenthesis. So let's talk about how many x's we have and how many y's we have. It looks like there are just 3 x's, but notice that I've got, technically then, we've got 2 y's, another 2 y's, and another 2 y's. So we technically then have y to the 6th power. So thinking about what happened, what did we do with our exponents? If we go back to the original problem, once again, y was technically to the first power, or sorry, x was technically to the first, y was to the second. Both of them are raised to the third power. So how did 1 and 3 turn to a 3? Well, multiplication. How did 2 and 3 turn to 6? Multiplication. So 1 times 3 got us that 3, and 2 times 3 got us the 6. We multiply. But it was that we had to multiply several sets of exponents. So here's our formal definition. To find a power of a product, we are going to find the power of each term. And when I say power, I mean exponent. And then we are going to multiply. Okay, so here's our formal definition. If I have x to the power of m times y to the power of n and that whole thing is to the power of p. Keep the base of x, but m times p, and then keep the base of y, and then n times p. So essentially, we are distributing the outside exponent to every exponent inside. So let's do some practice. Notice that in this first example, we have three things in parentheses. We have a 5, an x squared, and a y. All of that is raised to the third power. So we are going to keep each base, but I first want to identify what exponents I have. 5 is the base. If I don't see an exponent, there's really a 1 there. X is a base. It has an exponent of 2. Y is a base. If I don't see an exponent, there's technically a 1. So what I'm going to do is I'm going to keep the base of 5, but then its exponent of 1 gets multiplied by the outside exponent, which is 3, because I'm basically distributing it. Then I keep the base of x. Its exponent was 2. Because it's a power to a power, I'm basically distributing that 3, so they get multiplied. Keep the base of y. Its exponent was 1. The 3 is going to get multiplied by it, so we have 1 times 3. So notice that, keep the base of 5. 1 times 3 is 3, so we have 5 to the third power. Keep the base of x. 2 times 3 is 6. Keep the base of y. 1 times 3 is 3. Because that number base 5 has an exponent of 3, we can very easily multiply that out. We're thinking 5 times 5 times 5. Go ahead and use a calculator if you want, but 5 times 5 times 5 is 125. None of these exponents have a negative exponent, so we don't have to worry about doing anything else. All of the bases are different. All the exponents are positive. We are done. If I look at the next problem, we've got several things in parentheses. We have a 2, which really has a base of 2, which has an exponent of 1, and we have a base of x with an exponent of negative 3. But both of those are raised to the negative first power. So I keep the base of 2, keep its exponent, but then it gets multiplied by the outside exponent of negative 1. Keep the base of x, keep its exponent of negative 3, but then that has to get multiplied by the outside exponent of negative 1. Well, 1 times negative 1 is negative 1, and negative 3 times negative 1 is positive 3. Because we see that my final answer contains a negative exponent, this is not my final answer. We have to keep going. So because I see a negative exponent, I'm going to think about my fraction. I'm going to put it over 1. I only want to move the terms that have negative exponents. So it looks like this base of 2 has a negative exponent. That is going to get moved down. But the x, which has a positive exponent, that's going to stay where it is. So x to the third will stay on the top. The base of 2 gets moved down, which changes its exponent to a positive 1. So you can keep that exponent of 1 if you want, or you can just write it as x to the third over 2. Either one of those would be our complete answer. All right, let's look at a couple of problems where we have to find the missing exponent. So notice that we have an unknown. I'm going to call that x. But on each side of my equation, notice that I've got a base of 3 on the left, and I have a base of 3 on the right. So that's good. As long as they have the same base, then we get to ignore the bases. However, because this was a power to a power, that means that the exponents on the left have to be multiplied. So I want to multiply 6 and x together, and it's going to equal the exponent on the right, which is negative 2. So how do I get x by itself? Well, I'm going to divide both sides by 6. So negative 2 divided by 6 is actually going to be a fraction. I'm going to reduce this down. Both of those numbers are even, so both of them have a 2 in common. Negative 2 divided by 2 is going to give us negative 1 on the top. 6 divided by 2 is going to give us 3 on the bottom, and so that means that that missing exponent was a negative 1/3. If I look at the next problem, once again, I'm trying to find the missing exponent. I'm going to call it x. On the left, we have a base of d. On the right, we have a base of d. So that works out nice for us. What we're going to do then is we get to ignore those bases, but a power to a power on the left means multiplication. So I get to multiply the negative 5 and the x together. On the right, it's going to equal that exponent of 15. So I'm going to then get x by itself by dividing both sides by -5. 15 divided by -5 is -3. So -3 would be my answer. All right, that is what I wanted to get through today. Hopefully it's starting to make sense. We'll practice more together in class later.